Introduce Maite Taboada. Maite is a professor at the Department of Linguistics at Simon Fraser University in Canada. She's also associate member of the School of Computing Science at the same university. Maite is Spanish. She's originally from Madrid. She graduated in English philology from Universidad Complutense. And then she started a PhD in English linguistics at the same university, Complutense. But then she took a break and to complete a master in computational linguistics at Carnegie Mellon University in the US. And she participated in different projects at the Language Technology Institute in Carnegie Mellon, where she implemented a system to keep track of context and to improve the output of machine translation. During her PhD, she worked analyzing conversations and studying different aspects like coherence, cohesion, and thematic relations. And before finishing her PhD, she moved to Canada, where she held different positions at the University of Alberta in Edmonton. And then in 2000, she moved to Vancouver and she joined a company called Mindful Eye, where she was in charge of developing a system to track online opinions. Then in 2001, she moved to Simon Fraser University, where she's now a full professor. I think it's a very good opportunity for us to have here today this talk. Maite is very well known across the world for her contributions in computational linguistics, for supporting different tasks, and we really thank her for her to be here today. Thank you.
Thank you. Thank you for the introduction and for the invitation to be here today. Quería también aclarar que la charla la voy a dar en inglés, pero si hay preguntas o cualquier otro tema en castellano, incluso con galego, me puedo atrever. So, I'm going to talk about sentiment analysis beyond bags of words. So the take-home message, what I want to say at the end of the talk and what I want you to remember are two big questions. One is why sentiment analysis is difficult, and the second one, how can discourse help? So that's kind of what I will try to answer throughout the talk, but in case you want to tune out, I'll give you the answers right now, in case you don't want to wait. First, why is sentiment analysis difficult? Because evaluation is multifaceted. I'll explain a bit about sentiment analysis, but basically it's the task of figuring out evaluation. And evaluation happens at many levels of discourse and in many places, so it is difficult to pinpoint exactly where evaluation is. And I think discourse can help because when you get bags of words approaches that I'll define, but basically you look at a text, a tweet, or a headline, and then you just have words, and you take the words and you throw them in a bag and count what they are. Sometimes you miss a lot of information that is present in the discourse. So what I'll try to show to you is how the discourse information can help. So this is the roadmap for the talk. I'll talk about sentiment analysis and current approaches. I know many of you have done a lot of work in sentiment analysis. There's a good group here with very interesting papers on sentiment analysis, but for those who don't know it as well, I'll talk about it a bit. And then why it's difficult and how discourse can help, why discourse is important. So let's start by talking about sentiment analysis. I always like to say we live in a sentimental age. It seems that it's one of the fundamental aspects of human nature and of language that first we start out, even as babies, expressing desires and needs. You have some very basic needs that you need to be met, but then the next thing that happens is that you express emotions and evaluation. So when you're feeding a child and they throw the food on the floor, there's a clear expression of evaluation going on there. It's kind of after saying I am hungry, the next thing is I don't like the food, and that's, as I said, I think common to humans, but we seem to have experience an affective turn. In many of the social sciences, in philosophy, sociology, and political science, there's this term of the affective turn, where we not only look at facts and theories, but we also evaluate the reception and how they are perceived and how they are affected by emotions. Affective computing has been along for a long time. Rosemary Picard coined the term in '97, but there's a lot of work in human-computer interaction, for instance, that takes into account the emotions and the affect of the user. And of course, in social media, we seem to express feelings more frequently and more openly. So there's some cross-time studies that seem to say that in language we use more subjectivity. The Viz, Sanders, and Sporn paper is a paper that looks at news media over, I think, over 100 years. And they say we use more stance markers, more markers of how we perceive things. And there seems to be a style to a change to a more conversational style, even in writing. And one of the characteristics of conversation is that we express more evaluation, more subjectivity, more emotions. And then what happened is that we go social media. So this is all in the context of, in general, more conversational, more stance markers. And then we got all these ways in which we could evaluate, talk about different things on social media. So there comes sentiment analysis. So what I'll try to do here is define it. It doesn't matter whether you call it sentiment analysis of opinion or opinion mining. People talk about sentiment or evaluation or subjectivity. For the purposes of the talk today, it doesn't really matter. The task that I'm going to talk about and the task that we've been doing in my group is classification of texts. And text can be very broadly defined as a whole document, like a review, a blog post, a tweet, a sentence, a headline. There's a lot of work on headline classification. And the classification is based on subjective content, also known as sentiment, into positive or negative. So basically, you take a text, you do something with it, and you output a value for the text. It can be a number on a scale, or it can be binary, positive or negative. Why is this useful? A lot of the work has been done on movie reviews. You can search for a movie and see how many people have liked it. And these days, there's a lot of star opinions out there. So if you go to a lot of the movie review websites, the writers already have stars. They say, oh, I give it a 1 or I give it a 5. But in some cases, with professional reviews, you don't have that information. So it's useful to be able to classify it automatically. Consumer reviews, I think hardly anyone buys anything these days without at least looking at some of the reviews online. Market intelligence, and in politics, there's a lot of interesting research right now on the American election and the sentiment there. So it helps companies, it helps customers, it helps politicians. This was a survey published a few weeks before the Brexit referendum, and boy, they were wrong. The opinion on social media was that Britain would remain. I mean, there was not a huge difference. And then the other interesting thing with sentiment analysis is that it has been shown to improve other NLP tasks, other natural language processing tasks. So information extraction, question answering, multi-perspective question answering, summarization, authorship, attribution, word sense disambiguation. So for instance, in word sense disambiguation, if you know you have an evaluative text, you may be able to disambiguate the words. You may be able to tell which sense of the particular word is being used. For instance, the word novel can be a noun without much sentiment, or it can be an adjective, like a novel idea. So that helps disambiguate the sense of the word. In financial information, David mentioned that I worked for a company. This is exactly what I did many, many years ago. In the year 2000, the beginning of the dot-com boom, that then went bust. What we were trying to do was to map the market price, the S&P index or a particular company, to what people were saying about that company online. Back then, it was bulletin board posts. There was no Facebook, there was no Twitter, there was none of the Web 2.0 media, so it was bulletin board posts. And we were working on this correlation, and that's still being done today. And in fact, the word sentiment comes from initial use of sentiment, the sentiment of the market. Now, what I said, sentiment tries to divide words into positive or negative, and that has many meanings. One of them is a headline: is this good or bad news? Do people like or dislike something? Is the candidate likely or unlikely to win? Is there support or opposition for a particular policy? Pros and cons of anything, of a product or an idea. In medical texts, there's a lot of research on whether the text says, well, the patient showed improvement or not. And then whether people agree or disagree with the topic, and a sub-area of sentiment analysis, argumentation mining, where you look at statements pro and con in a debate for or against the topic. Gun control in the United States. So the goal is to figure out what the argument is and whether the argument supports or not the idea. So in terms of polarity and strength, just for instance, if you get a review of a restaurant, you get polarity there, right? But also strength in the number of stars or number of points. And another area in sentiment analysis is looking at features. So you can have, this is a restaurant in Madrid. I'm hoping to go one day because it looks really good. So 4.5 stars for the restaurant overall. But then you have different aspects. So the food is the best, the value is not so good, so maybe it's an expensive restaurant. The service and the atmosphere are very good. So those are sort of different aspects that contribute to the overall rating, but you may want to know that, right? So if the food is really good, but the value is not so good, maybe it's expensive. And then I'm going to say just one thing about emotion, which is I'm not going to talk about it anymore. Emotion is a whole other area, sometimes overlapping with sentiment. I want to say emotions are not sentiment. There's a huge area in classification of emotions and different classifications of emotions: anger, fear, surprise, happiness. There's the 5, if you've seen the movie Inside Out, there's the 5 basic emotions that they say every human has. But when you are classifying emotions, the classification methods are a little different, and the textual indicators are a little different. Very interesting, but unrelated to what I want to say today, or not wholly unrelated, but not directly. So, how do we do this sentiment analysis? What are the current approaches? So, the computational treatment of sentiment, one of the best definitions that I know is by Bing Liu, and then he defines opinion as a quintuple of 5 different components. So you got the entity that you're talking about, an aspect, a sentiment, the holder who holds the opinion, and the time it was posted. This is particularly the time, particularly important in online media, where you want to know when the review or the information was posted. And then sentiment is also composed of different things: the semantic category, the orientation or polarity, and the intensity. So let me give you an example. This restaurant serves incredibly delicious food. The opinion is, first of all, the quintuple is about the restaurant. The aspect is the food, right? It's not the atmosphere, it's not the price. And then the sentiment is maybe appreciation, and then this refers to semantic categories. What type of opinion is being expressed? The orientation is positive, and the intensity is high. The incredibly makes it high. And then it was posted by Chris Smith, and it was posted, I made this up, a few days ago. What methods do we use? So basically, 2 general approaches to sentiment extraction. This is from a recent review in Annual Review of Linguistics. The machine learning approach, what you do is this is supervised learning. So you get a set of training data, a set of headlines that are all positive about good news, and a set of headlines that are negative. Then you extract a set of features, and you learn from those features how to classify documents or tweets or blog posts into positive or negative. So you build a classifier, and when you get new data, the classifier predicts whether something is more like the positive training data or more like the negative training data. In the lexicon-based methods, you get a development phase where you get dictionaries, a set of words that are known to be positive and known to be negative, and a set of rules for how to deal with those words. So then when you get new data, you extract words and apply rules to that data, and then you predict that it's going to be positive based on those rules that you've created. In lexicon-based approaches, what you do is you build dictionaries in different ways. But basically, one of the ways is by saying, okay, there's a word here is next to a positive word and joined with and, so then this word is positive. It's next to a negative word and joined with but, therefore that word is negative. There's also manual creation of dictionaries, and the dictionaries that we have created at SFU are manual. Techniques used to do this, first of all, pre-processing, you need to do some lemmatizing, sometimes stop word removal. Stop word removal is very common in information extraction, and it works very well. But in sentiment analysis, some of these little words actually are very important. So when you get negation or you get but, you shouldn't remove them. You shouldn't do a stop word removal with those. There's some text normalization, especially for things like Twitter, SMS. And there's all kinds of different things. Syntactic parsing, I know some of the people here have done dependency parsing. And then the features that you look at, so if you look at the features that are extracted here, for instance, in machine learning, there are different types of things that you can do. Features, term presence or term frequency, TF-IDF is common in information extraction and topic classification. What we found in sentiment analysis is that sometimes term frequency is not as useful. Term presence, so just whether the word is there or not how many times it appears. Parts of a speech, negators, and so on. And then you can do feature selection with different algorithms. Now, when you get lexicon-based methods, you get a set of words, a set of dictionaries, and then you process a new text. You get all the opinion words out of it, and you get a list of opinion words. Now, what do you do with those words? How do you do the aggregation? So one is to just average, right? So 10 positive words, 1 negative word, the text is positive. Right? The second and more sophisticated way is find out more about the context, and that's where I'm going to talk a little bit more about discourse, right? Is this at the beginning or the middle or the end of the text? What kind of text is it? What kind of domain? With lexicon-based approaches, some of the problems is that the dictionaries are static. So you get a dictionary for a particular domain, and then you cannot change it to a new domain unless you do it manually. And the other thing is, in different contexts, you may have different meanings. So loud for a phone may be good. Like, let's say you have a speakerphone where you're going to have a meeting. It's good that the phone is loud and clear, but maybe in a restaurant that's not good. Right? Unpredictable and unpredictable movie may be a good thing. Unpredictable computer, not so much. So sometimes you have to do some domain adaptation. In machine learning approaches, you get supervised or unsupervised learning. I'm not going to talk so much about unsupervised, but in supervised learning, you get annotated corpora. And then, as I said, you can do polar information, so positive or negative, or you can have a scale. And there are different algorithms to do the machine learning stuff. Now, with statistical methods, with machine learning methods, the problems that we've found, and that's why I advocate for a lexicon-based approach, is that feature learning can be too specific. So we did an experiment a few years ago. We got the polarity data set, a set of 2,000 movie reviews, and then we built an SVM classifier. SVM classifiers were very popular for a long time. So we took the most positive and negative n-grams. So some of them were quite predictable. What does it learn as you feed it documents? It learns that worst, waste, unfortunately, and mess are negative, and memorable, wonderful, laughs, and enjoyed are positive. So far, so good. It learns some things that we couldn't quite explain. So if the review mentions performances, ending, or flaws, that's positive. An interesting thing is flaws. Mentioning flaws is positive. If the review mentions the writer, the director, the plot, or the script, then it's negative. But the other interesting thing is what has been called the Angelina Jolie effect. So you get overfitting, basically. The polarity data set was collected around the time that Tomb Raider 2 came out. I don't know if you've had the pleasure of watching that movie or the agony of watching it. I haven't watched it, but from the reviews, I don't want to. Tomb Raider 2 had Angelina Jolie in it. So if you feed a machine learning classifier this set of 2,000 movie reviews, it learns that a movie with the word Angelina or Jolie or the bigram Angelina Jolie is a bad movie. So this is not consistent over time. This is learning too many features, right? It actually has been called now the Angelina Jolie effect. And the other interesting thing that our SVM classifier learned is that the unigram 2, video, and TV are negative. Can you guess why those things are negative? Tomb Raider 2, video game, because Tomb Raider was a video game, so movies out of video games are bad. And TV, maybe movies made out of TV characters are bad. So that's a little too specific, right? And then the other problem with statistical methods is that you get poor cross-domain performance. So that's something to take into account when you do statistical approaches. And in general, a very important caveat, this is a very recent paper, published July 7th, 2016. I don't know this group at all. It's a group in Brazil, but a really, really good paper. They took 24 sentiment analysis methods. Some of them they re-implemented, some of them they got from the authors. They used my method as well. And they got 18 different data sets. And they run all the methods with all the data sets. And what they found is there's no single method that always achieves a consistent rank position for different data sets. So depending on which data set you have, some methods will work well and some methods will work badly, but you cannot predict. So they say, before using a sentiment analysis method, it's crucial to test different methods. So don't just say, oh, I've heard that Maite Taboada's method works well. I'm going to use it on my data set. It may not work very well on your particular data set. So that was really interesting. And I think it's the best and the most extensive test that I've seen. So let me talk then about why this is difficult, why we have so much trouble, and why some methods work well and depending on the data set. We have lots of initial progress with what we call bags of words approaches, right? As I said, let's talk about movie reviews. You get a movie review with 10 positive words and 1 negative. You take all the words, you throw them in a bag, shake it, and count. 1, 2, 3, 4, 5 positive, right? And I think what we are is at the 80-20 position. The 80-20 rule says that you get 80% of the results from 20% of the effort. So I think we've employed 20% of the effort. I know it feels like we've done a lot of work already, but we've done the easy approaches. The Pareto Principle is a similar principle. So to achieve the other 20% of the results, we need 80% of the effort. Which I know is depressing, but it's also an opportunity, right? We'll have work to do for years to come. What do we need? What is the 80% that is missing? I think we need a whole text approach when you look at longer texts. When you look at shorter texts like Twitter, you need to look at threads. What context? This is context. Even if the text is very small, it appears in a particular context. And a lot of the work, I'm not doing this work, but a lot of the work that has been done is information, not just about the context, the verbal context, but about the users, about their social networks, who follows them, who are they following, what kind of social network do they have. And there's work on textual entailment and intent detection. So sometimes when somebody is posting a review, it's interesting to know whether they have an intent to buy or not. So for instance, talking about the 80-20 rule, this is our method that we developed a few years ago. The best description is a 2011 paper. And our method is sentiment or lexicon based. We have a set of dictionaries, adjectives, nouns, and so on. We use intensifiers, we use negation, and we use the realis, modals, verse of opinion, and such. So there's quite a bit of linguistic information. And I think we have good performance on unseen data and good cross-domain performance. So for English, the stuff in blue is the development set. So this 400 opinions text is what we developed on. The performance is around 80%, and all of this is unseen data. And we do pretty well. In fact, in camera reviews, we do even a little better than for the development set. We also have a Spanish version that doesn't work as well. That's in part due to the part of a speech tagger, and it hasn't been developed as much, but it works well. But as you can see, the best we can do is 80%. So really, it's a very good example of the 80-20 rule. So how can we improve this? With all these other things. Words in context, out-of-topic sentences, irony, word knowledge, discourse structure, argumentation. I'm going to tell you a little bit about some of those. Negation. So basically, of course, we know that I like it and I don't like it are different things. But there's even more complicated things in negation. So there's negative words. So fails to entertain. It's not just good enough to know that fail is a negative word. You need to know that the word entertain is in the scope of that negation. So then you need to do some form of parsing. And then there's interesting what has been called partial negation. So I didn't like it until the end. If I just say, okay, like is a positive word, but it's negated, I don't really capture the opinion there, right? The opinion is, it took a while, but the real crucial part is until the end. So when you have until the end, then the negation is overridden. It means I liked it. It took a while, but I liked it. He didn't come until 7 means he did come. Maybe late, but he did come. So the didn't come is not negated. So negation is pretty complicated. There's different ways to deal with negation. That's from a classic paper now. Irrealis, also known as non-veridicality. So when irrealis, what we're saying is that the proposition is not factual. Right? So for instance, she will become a really good actress. You get opinion words there, good actress, but the will means that she's not there yet. This is positive, right? So you're saying she has the potential. It's not a negative thing, but it's not she's a good actress, right? So it's not as positive in terms of intensity as just stating it. I may like the movie, I thought. That's, there's a like there, but there's very attenuated. And then you get things like conditionals, a really good movie, right? But could have been, and if. So that's the kind of things that we need to deal with. There's also lots of out-of-topic sentences. I was looking at reviews of the movie The Martian, and a lot of them talked about politics, right? Why the Chinese do that, some, spying, and so on. So there's a lot of other things being discussed when you do, especially with movie reviews. So to deal with this, we've sort of expanded on Bingley's definition of sentiment. This is work that I've done with Farah Ben Amara in Toulouse. And remember, we had that definition where opinion is entity, aspect, sentiment, holder, and topic. So what we have is a new definition with update functions. So if you're going to do sentiment, you have omega is the old quintuple. We've dropped the top time because we don't think it's not important, but you can add time and things like that to it. So those are the So intrinsic properties of the opinion or the evaluation. But then we have a set of functions that are update functions, such that when you find something in the text or in the context that tells you you need to change, you update that intrinsic property. So those are the contextual updates. Let me show you how this would work. So for instance, you have a little text like, what a great animated movie. I was so scared the whole time that I didn't even move from my seat. So you may start, remember this is the intrinsic properties. You may start with, okay, movie is the entity being evaluated. I've left aspect out because there's no particular aspect. This is a definition of the whole. And you say great, and the polarity and the intensity of great is +1, and the author is the holder. The author stays constant. Okay, and then you get to scared. And in scared you say, yes, it's about the movie, but scared is a bad thing, right? It's bad to be scared. It's one of those emotion words. So maybe it's a -1. And then you intensify it with so. So because it's intensified, you go to a -2. But then you say, oh, hang on, there's an update from the discourse. I was so scared comes after what a great movie. So in this context, and in the context of maybe a horror movie, scared is positive. So the contextual discourse update changes that scared to +2. And then I didn't even move from my seat. There's not a whole lot of evaluation words in there, right? Not moving could even be negative, right? But in the context, in the pragmatic context of a movie and a horror movie, that is a good thing. So then you have so scared is positive, and didn't move from my seat is even more positive. Now, we don't tell you how you're going to figure this out, that not moving from your seat is a positive thing, but we have the framework to put that in, to do updates at the sentence level, at the discourse level, and at the pragmatic level. And that's a paper. It's about to come out in computational linguistics. We just got it accepted. It's available online already from my website. So how are we going to do some of this? Some of the updates, where are they going to come from? Why is discourse? So as what I've been saying, contextual information, I'm going to talk about 3 aspects. Sentences towards the end of the text tend to contain more information. In certain texts, there's a fair amount of description that is not relevant to the text, or like I said with the Martian, description of political issues, and then discourse relations in the text. So let me go through those. First of all, position in the text. This is a pretty old work with Jack Grieve, who's a former student of mine now at Aston University in the UK. And it's a very simple idea, but it works really well. If you get a longer text, opinion seems to be concentrated in certain areas of the text. So with movie reviews, we found that most of the sentences in the 2/3 mark were important. So we weigh, we don't disregard things at the beginning, but we weigh them less heavily than things that appear sort of more towards the middle. And that worked really well. The second aspect is functional zones. This is work with Julian Brooke and Manfred Stede. And then what we did is figure out whether something is describing the plot of the movie or evaluating the movie. Because if you say the character is a terrible villain, that's not negative about the movie. It's just a description of the characters or the plot. So what we did is basically we built a classifier to identify the parts of the movie review and then did weights differently. I'm going to sort of go through this quickly, but basically we have a taxonomy that says this part describes, this part's comment, and then there's structural elements. There are things like the title of the movie or the description of the characters or the list of casts. So what we did is we annotated a set of movie reviews with, is this paragraph, and this was paragraph based, describe or comment, or describe and comment. So that's sort of the classification scheme. Right? So this is the annotation. We said, okay, this is title, this is the author of the review, this is background, this is evaluation, this is part of the plot, and so on and so forth. So different chunks of the review. And then we built a classifier using either n-grams or using more linguistic information, so that we know that, for instance, pronouns, adverbials, intensifiers, and modals are more frequent in evaluative text. We also use discourse markers, so descriptions of the plot have more temporal markers. This happens, and then this other things happens, and finally this other thing happens. And when you are evaluating, there's more contrast and comparison. So we built a classifier, different classifiers using that. Our classifiers don't work really great because we didn't have a lot of data. So the overall accuracy is about 71, 78 for the best one. But then we still use those to weigh paragraphs. What we did was, on this polarity data set, on this collection of movie reviews, we label the paragraphs and then we run our system SOCAL on the texts. This is the results. This is the baseline. The baseline is, I think, 77.7%. If we don't change anything, if we just run SOCAL, that's our baseline for the text. With the different classifiers, this is the weight on the description paragraph. If we say we completely disregard those paragraphs, we sometimes do better than the baseline, sometimes we do worse. But if we give those paragraphs a lower weight than just one, we tend to improve. And one of the classifiers improves the accuracy to 79%. So in general, most classifiers improve performance. So if we say, okay, this is description, I'm going to lower the weight of the description and leave the comment intact, we tend to improve. And we know we're not doing that well because the classifier doesn't work very well. So sometimes it labels something a description that is actually evaluation. Right? If we use the manual annotations, the performance, it goes up by 12%. So we want to keep doing this with a larger data set and better classifiers. So clearly it's a good avenue to pursue. And then finally, the other aspect of discourse that I think is relevant to sentiment is discourse structure, the rhetorical or discourse structure of the text. This is the same principle that I was telling you earlier. Opinions tend to go towards the end of the text. Concessive relations are used heavily, and sometimes you can ignore elaborations. This is one of my favorite examples. This is a review of or part of the review of the movie The Last Samurai, Tom Cruise. Some of these examples are from about 10 years ago, which is when we collected data. But this is a beautiful example of how bags of words don't work. So you see lots of positive words, right? Do you think this is a good review? No, right? And the punchline, the last sentence in that paragraph is, but other than that, this movie is nothing more than hidden ripoffs. And you knew that because could have been, it's sort of building there. But if you just look at the words, there's a lot of positive words. What happens? Well, the structure of the argument is that this is the main part. This movie is just copying a whole bunch of other movies. That's what a ripoff is. And the review goes on to talk about how there's all these other movies that are better, right? And then all of this noise, what in classification we would call noise, contributes positive words. And those positive words are important, but the real key is in hidden ripoffs, right? So then you have to do a relative weight. You have to say, this is the most important thing, and this is contributing. And this is very common in evaluation. You say a lot of good things. I liked it, I write letters of recommendation for students. Well, a student is good, and he or she does all these other things, and you kind of build. You have to say the positive things first, right? And then sometimes the negative evaluation comes later. So this is based on the idea of rhetorical relations. I think in the interest of time, I'm going to skip this part, but is the idea that I've told you that you just build a structure for the text. This is called discourse parsing, the same way that we do sentence parsing. That's another example of that. And I'm really glad to see that I'm not the only one thinking this way. This is a recent paper in Communications of the Association for Computing Machinery. And basically, they say exactly the same thing that I've been thinking, that the traditional sentiment analysis relies mostly on word frequencies, and then you don't get the nuances in the text. So you need rhetorical structure, you need discourse structure. And that's what we're working on now in my group. In conclusion, I would like to say sentiment analysis is hot, is an expanding area, is an area that we keep doing a lot of work on, and there's a lot of work in Spain. There's the Taller de Análisis de Sentimiento and CPLN, so there's a lot of really good work. But, it's a hard problem. We've tried all the easy approaches. We've done the 80-20, and now we have to tackle discourse and context. I had a little bit on other work that I'm doing. How are we doing for time? Can I take like 2-3 more minutes? I just want to tell you about another current project that we're doing. This is more linguistic, but I think it's going to provide interesting data. We're working on online comments. So you get an opinion piece in a newspaper or even a regular article, and then you get comments, sometimes at the end of the article. This is a recent article from the Vancouver Sun, and lots of comments. Sometimes people just use their Facebook login to provide the comments, right? So you've all seen that, right? Interesting thing is that comments can be so nasty, and they're so nasty in such a creative way. So many websites have decided they're not going to allow comments because they cannot monitor them. Fortune had an article saying, have media websites just given up on comments? Are they useful? Are they not? This is from CBC News. CBC is the Canadian Broadcasting Corporation, is the Canadian equivalent of the BBC. And they just had an editor's blog on comments, on how uncivil they are. So what they found is that stories about Indigenous Canadians, so there is quite a big population of First Nations people in Canada, where they have to draw the line. There's hate speech, which is a codified crime, and it seems to be unique when it's Indigenous-related stories. They draw a disproportionate number of comments that cross the line and violate guidelines. The Guardian also did a recent analysis of their comments. So they have 70 million comments since 2006, and they classified them as to what topic they were about and who the author of the original article was. And this was interesting and disheartening. What they found is they have a sort of ranking of abused writers that received the most abuse, and they analyze comments that had never been published. So in some cases, they have media managers and community managers, and those comments get blocked. They don't even get published because they're so bad. So the 10 most abused writers, 8 were women, and the 2 men were black. So there seems to be a lot of nastiness online, and that's why I was interested. So I embarked on a project on online commentary. It's a long-term project where we're going to be looking at subjectivity and opinion and the editorials and the comments, and we're going to annotate them with negation, speculation, the scope, and see if we can figure out how exactly people are nasty online. That's sort of studying negation. We're going to focus on the 2 national Canadian newspapers, and the goal is to collect at the end of the project 10 million words of text. Well, collecting is easy, annotating is the hard part. So we're going to annotate them with negation, scope, appraisal, so different types of evaluation, those non-veridical irrealis operators, and coherence relations. So eventually we'll do some machine learning, but the plan is to make all this data and all the annotations available so that other people can use them as well. I'm going to skip the annotation, but basically that's the types of things that we want to annotate. So that's it. Thank you.
Thank you. Any questions? Sotan?
Okay. I want to ask about the lexicon. As you show here, the lexicon is the words, if it's negative or positive.
Yep.
And you know, in movie review, the words different than the other. Movie review, I think, is a special case because it contain many things. Discuss the characters inside the movie or other thing. So, did you think it's better to make a lexicon for movie review, a special lexicon for movie review, another one for customer review, or I mean, we need many lexicon for the sentiment analysis. Do you think it's better or it's a good idea?
Yeah, we've done all kinds of experiments. That's a good question. Thank you. We've done all kinds of experiments with lexicons. So one was to have as many words as possible. There's a lexicon out there that I think has, well, I don't know, something like 7,000 or 10,000 words. If you use too many words in your dictionary, it gets worse. But I think that there is a difference between movie, book, and music reviews. So basically reviews about works of art or artistic products and consumer products. I think that's, is completely different. If you can do it, you can have separate lexicons. I know people have hotel as well, lexica, and if you're working on hotel data, and that sort of goes back to that paper, the Ribeiro et al. Paper, where know your data. If you know that you're only going to be dealing with hotel reviews, then build a lexicon. People say, oh, well, but it takes so much work to build a lexicon. It's not really that much work. It takes a bit of curating, a little bit of going through your data, but you can get a really good lexicon for specific data. If what you want is an all-purpose sentiment analysis software, then sometimes you have to compromise, and sometimes the words will not work as well. But if your data is going to be uniform, it's better to have a specific lexicon for your data. Yeah.
Thank you. Any other question?
Another thing, do you think the number of words in lexicon, I mean, there are many lexicon with thousands words.
Yeah.
Another one with as your lexicon, SO calculator. I think for adjective, it's around
2,000-3,000 for English.
Yeah, for English. So, do you think the number is makes sense when you work in lexicon?
What we found is that more is not better.
Yeah.
So more words. So there's CentiStrength has a ton of words. Some of you know CentiStrength. And then there's this by Saif Muhammad also that that has a ton of words. It doesn't work as well because it catches every word.
And FINN lexicon also.
Yeah.
No, I mean when I compare three lexicon together, for example, this one has 1,000 and this one 3,000. Do you think it's fair to compare it with the different number of words? Every dictionary has different number of words. Do you think it's better to make an equal number of words in every lexicon to compare?
No, it depends on what you want to do, right? But as I said, if you have more words, that's not all, because you get noise, basically, right? If you use a lot of words, then you just get noise. So sometimes it's better to use fewer words and do some of those more sophisticated things, right? To figure out, okay, well, that's in realis, I'm going to discount those words. That's at the beginning of the text, I'm going to discount those or lower the weight. Yeah. Some other question there?
Hello, thank you for your excellent talk.
Thank you.
And the question is about argument structure. I didn't see, maybe
I went through that a little quickly,
about the results you obtained. So with argument structure, because your results were, when you improve a little, was using classification
Yeah.
of the segments
Yeah.
in the text, but I didn't see if you improve using
No,
argument structure.
that's a very smart question. No, I didn't provide results for that because we don't have results. One of the problems with this is that you need to parse the text correctly, right? There's no really good discourse parser now. One of my colleagues at the University of British Columbia has developed one, Shafiq Jyoti and Giuseppe Carenini, and we're in talks to use their discourse parser with SOCAL to see how that works, but we have no experiments with it. We did an experiment years ago where we didn't have the label, we didn't use the type of relation, we just said this one is the most important one, and this one is the less important part. And it worked pretty well, so you do improve, but the labeling, the classification of, this is called the nucleus and this is the satellite, the most important and the less important part, the classification was not that good with the system that we had back then. The discourse parsers that are now available work a little better, but I haven't tested one yet. That's also a work in progress, yeah.
Hello, my name is Haysam Marouf. Thank you for this amazing lecture. The clinical field is a very critical field, and in general, physicians, after testing their patients, they write their reports using natural language text. And some researchers suggested that it is better to store the result as code, for example, as values, because it is easier for us to analyze, to do statistics. Do you think natural language processing can offer a good solution to try to find the comparison between different patients, the similar in symptoms? Is it effective, you think?
Yeah, there's lots of research. I don't know it as well. There's a lot of research on clinical data, summarization in particular of clinical data. So, the doctor might, talk about the patient presented with these symptoms and we did this treatment and the blah, blah, blah. But then there is, and this is what happened. The patient improved or not, or this is the recommendation, right? There's research on radiology reports, there's research on diagnosis, and I know some of it works well, especially the summarization. Summarization is I think improving all the time and getting better. So there's research on that. There's also a lot of research on biomedical articles. So there's just so much research being published in the field that you cannot, as a PhD student, if you want to make progress, you first of all need to know everything that has been done before. But there's no way you can read it all. So there's research trying to summarize the findings as well. And yeah, I think a lot of that is useful. Yes.
Okay, thank you.
Any other question? We had some experience using RST with data from blogs. Actually, we had this collaboration with the team from the Netherlands, the teams that you mentioned in the.
Oh yes, that's
and,
right.
One of the problems that we have is actually related to what you've mentioned about parsing, right? Because essentially we use just the sentence level analysis. We were using Spade, right?
And Spade is pretty awful.
And
Sorry, well, it is.
First problem that we had is that we couldn't use Spade on the whole data that we had, but we had to include an initial sentence retrieval approach to filter out many sentences to focus on topic sentences. But apart from that, the problem that we had is that many times the software fail and everything, and we just focus on a basic high level analysis between the nucleus and the different types of satellites. But I think it's really interesting if we have this more sophisticated parsing, connecting different sentences from a long text. We were working with blog posts that were relatively long and
it's a form of summarization, right?
Exactly.
And Spade is, I said it's awful. It's 10 years old. and things have changed so much. So there are better things now. The Spade is, the advantage is that it was freely available, it was easy to install, we could all use it. But there are better systems now. There's, the system from the University of British Columbia. There's a team in Germany as well, Hilda. So I think we'll do much better. But the idea is, it has a lot of promise, I think.
Yeah,
you
sure.
have long texts, some parts are more important than others. So if you can find those more important parts, even with some error, the sentiment analysis will be better. Yeah, I think so.
Okay, and you mentioned briefly intent.
Intent detection, yes.
I'm
yes,
not
yes.
familiar at all with the research in this area. Can you tell us a little bit about?
Yeah, so we have a little bit on that paper with Harvey and Amara on intent detection. So the idea is to figure out, and this is in real time, are you, for instance, when you post a tweet or when you do a blog post, what it is that you want to buy, what it is that you want to do, or what it is that who do you want to vote for? And this is detecting not just your current opinion, right? I like this movie, but the future opinion. So, we had an example in the paper. If somebody says, posts, I'm 6 months pregnant, and starts looking at sites for, I don't know, cribs, then you can detect that they have an intention to buy a crib in the near future, and then there's a lot of the personalization and recommendation systems, right? So it's detecting what it is that is going on and what you say means for the future. Yeah. So we have some references in that paper as well. Yeah.
And the work that you mentioned on functional zones, that as far as I understand, it's a supervised learning approach.
That's supervised, yes.
And
yeah.
you label the passages, right?
Yeah.
So is this data available or?
Oh yeah, for sure. Yeah. We have only, I forget how many texts. I think it's about 100 paragraphs. So not a lot, but it's I can give it to you. Yeah.
Okay. Any other question? Any question from YouTube? Okay. So thanks, Maite, for this talk.
De nada, gracias.